All right, let's look at the complex log functions. All right, let's say z is a complex number, so I'm going to use the exponential form r e to the I theta. All right, so let's try to understand natural log of z. All right, so I'm going to let natural log of z equals, say, w. Right, then try to find w. Right. So using the definition of log, we should be able to write it as, right, so log goes from z to w, so exponential function e to the w is going to be exactly equal to z, right? But the z, we can write it as r e to the I theta, and also, r can be written as e to the, right, so this is a natural log, e to the natural log. I'm using a capital letter so that this is a regular real number, natural log. Right, so this is the, and I've just put, this is the real natural log. All right, then so that's the same thing as r. Then you have e to the I theta, which we can combine in as a single exponential expression, e to the natural log of r plus I theta. All right, so it's natural to say we're going to try to match this w to natural log of r plus I theta, right? So therefore, we have w is natural log of z is going to be natural log of r plus I theta, right? Then you can see that here r is simply the absolute value of z, right? So it's very easy to find, and theta is going to be simply the angle of z, right? So natural log of absolute value of z plus I times the angle of z, right? So let's look at this following examples. Let's try to find natural log of negative I, right? So let's find r. All right, r is just the absolute value of negative I. All right, this is obviously equal to, it's square root of -1 squared, and so that's going to be just 1. Right? The angle wise, we can probably draw a picture. So let's see. Let's draw the complex plane. So here's x, and here is y. All right. Then since it's a negative I, so negative I sits right here. So here is -1, and this is going to be negative I right there. All right. So this is negative I. So the angle wise, we are looking at the angle right here. So angle is going from here all the way to there. So that would be 3 pi over 2, right? But that's not the any angle. We can actually only angle. You can add any multiple of 2 pi to get exactly the same effect. So theta is going to have multiple values. So theta is equal to angle of negative I, which is equal to 3 pi over 2 plus any multiple of 2 pi. Right? So what you get is, so the value of natural log of negative I is actually multi-valued. So here we have natural log of R is 1 plus I times 3 pi over 2 plus 2n pi, right? Then we know that the natural log of 1, because the capital letter 1 is a regular natural log, so this is actually 0. So therefore, we get I times 3 pi over 2 plus 2n pi, right? So this is the values of natural log of negative I. All right, so let's look at another example. How about natural log of 1 minus I? All right, so R, again, is fairly easy to find. Absolute value of 1 minus I. So this is going to be square root of 1 squared plus negative 1 squared. So that's going to be square root of 2. Right? And the angle theta is going to be, so it's an angle of 1 minus I. Alright, so let's draw a picture again. So you have, let's see, I'm going to do it here. And here's the y-axis. Alright. Then so real part is 1, so you have 1 here. And the imaginary part is negative 1, so right here. So we have point right here. Right? So this is going to be the 1 minus I. Right? So angle-wise, we can probably go backward on this one. The angle here is going to be negative pi over 4. Right? So we can say this is going to be negative pi over 4 plus any multiple of 2 pi. Right? So this is going to be equal to natural log of square root of 2 plus I times negative pi over 4 plus 2n pi. Right? So that's the values of, maybe I should be clear, n is any integer here, and here n is any integer. Right? So these are the value of complex log functions. All right, that's it. I hope that this was clear.